My name is Fernando Miralles-Wilhem, and I am senior water and sanitation specialist at the Inter-American Development Bank. I sort of have a double hat in that I am also a tenured faculty at Florida International University in Miami.
So mostly you move from a world where you're interacting with, say, other engineers, students, other types of academics, probably a lot of biologists given your work in environmental engineering, and then into an area where you're working with probably economists.
Yes, and yeah, and definitely, economists, policymakers, and who and this is where I mean, the gap that you perceive between science and policy. I've always known it's there, but you haven't really seen it until you really taste it and live it. The research was being done in Argentina, and the point there was to help farmers deal with El Nino, with ENSO. Because when you have a cold phase and we have a warm phase of ENSO, El Nino or La Nina, then you get very different rainfall patterns, that translated into different water availabilities. And given that NOAA was issuing these climate forecasts about a year in advance, it was a little bit surprising that people, in this case farmers, were not reacting fast enough to this information, okay? So at that point, we had the gap between science being available, so the forecasts are there, but for some reason, they were not being used to make decisions. Like, farmers could decide, well, if it's going to rain less, I'll switch crops, or I'll plant, different parts of, of my land. Nothing of that sort was being done.
Do you think that it's more at the level of an institution, say a government ministry or an agency, or it's more at the level of individuals, that people haven't gotten kind of conceptually acclimated to the process of incorporating new pieces of information?
Well, I've swung back on that response because a few years ago I thought, well, what's going on with these institutions that they're not making use of this information? Then when you start looking at from the user's perspective, then what you realize very quickly, and this has been documented by many colleagues out there, is what some people call the dumping truck model, which is where scientists, basically researchers like colleagues that you and I have had, including ourselves from time to time. Our goal is to get the paper published. So what we do is that we write the paper, and there's this whole analogy where you load the papers on a truck, you back it up on the policymakers, you dump it, and there's the science. You go figure it out what to do with it.
Now, do you see that climate change has really been changing the business of IDB?
Yes, absolutely. I mean, it has become a core theme of the institution.
Primarily from a climate mitigation or an adaptation perspective, or both?
I think it's both. I think it has evolved. I think it started more on the mitigation side, and it's now moved into the adaptation side. And we focused when climate change was realized. I think we focused on the wrong question, which was mitigation. I think it's important to reduce emissions, to do clean development. I think all those things are important, but by focusing on that, you basically polarize the debate between, again, the good guys and the bad guys. And so I think we've wasted a lot of time in finger pointing.
Can you give me an example of a project that you're working on that before trying to think about climate change adaptation, that the project would have looked very differently than it does right now?
So let's go to very basic infrastructure design. The principles, the engineering principles for design of those facilities take what are called a stationary approach, meaning that we take the last 30 years of climate and we assume that that's not going to change.
But as an engineer, as someone that's, say, part of a team that's trying to plan, design, and finance let's say a hydropower facility or an irrigation facility or water treatment facility. You want that facility to be able to operate efficiently and effectively for many decades. But if you're not really sure what the future is going to look like based on the last 30 or 40 years of data, then that puts you into a very difficult position.
But let me counter that, because I'm glad that you brought up this, because this is perhaps the perfect example of that gap between science knowledge and implementation. The math and the science are there. I mean, they've been there for the longest time. The fact that they haven't been translated to appropriate engineering design principles or guidelines for these systems is what, it's almost baffling. I mean,
do you feel like climate change is a game changer? Is it a really big problem, or that it's a kind of a fairly small, subtle shift to what we have been doing?
Well, I think it's an opportunity to really, do things the way we were supposed to be doing in the first place.
So that's the opportunity. What's the risk of climate change and getting things wrong?
Undoubtedly, we're going to get things wrong. I mean, I think it's a matter of trying to, being able to understand that this is not one of the situations where we're gonna get the answer and then we're gonna act and everything's gonna be all right.
Why is water important from a climate change perspective? Why do you focus on that so much? And do you think it should be that it's a separate sector?
Yeah, I mean, I'll give you the hydrologist's answer. I think. I tell students in my class that if you think about the planet as a body, as like the human body, then water would be the blood, because it's really the fluid that keeps everything moving from place A to place B. It cleans here, it provides nutrition there. It's got a whole variety of roles, such as blood in the human body. So. Because of that, it's extremely difficult, if not impossible, and I would argue that's actually impossible, to separate water as a sector or water as something that you can act on independently. And you can't get away with that on water. Anything on adaptation that you want to address, water is going to be involved. So it's almost like water and adaptation that join at the hip.